cyclist who is freewheeling down a hill. Let's represent her by a particle, and let's look at the forces which are acting. Now, the mass of the cyclist is 40 kilograms. In other words, her weight, which acts vertically downwards, is 40 g newtons. Now, there's no resistance to motion because you're told that, but there will be a contact force, so a straight line there, which is between the cyclist and the slope. Okay, so we are asked to calculate her acceleration down the hill, and in order to do that, we're going to use Newton's second law. And Newton's second law is basically that the force, now that's the resultant force, and that's going to be acting down the slope because her acceleration is obviously going to be down the slope. The resultant force down the slope must equal her mass multiplied by her acceleration. Now, the only force which is making her go down the slope is the component of her weight, which is acting in this direction. Now, the angle between those two is going to be this angle here, which is obviously going to be 84 degrees. So the resultant force which is acting down the slope is going to be 40g, so the size of the force, multiplied by the cosine of the angle between, so in other words, the cosine of the angle between the actual force and the direction in which we're resolving, if you like. And that's going to be 40g cos 84 degrees. And that resultant force, that's the only force that's making her move down the slope, is going to be equal to her mass, which is 40 multiplied by the acceleration. And if we want to work out the acceleration, obviously we're going to divide this expression by 40. The acceleration then comes out as 1.02 meters per second. Part B asks us to show that her speed therefore increases from 4 meters per second to 16 meters per second in about 117 meters. Now, we mustn't assume that 117 meters, we're going to find that. So we know that her initial velocity there is 4 meters per second. Her final velocity is 16 meters per second, and we also know her acceleration, and that's the 1.02 meters per second that we've saved from part A. Save that in your calculator memory. What we're trying to find then is S, and we're going to just use b squared equals u squared plus 2as. And if we substitute into that, we've got 16 squared is going to equal 4 squared plus, and that's just going to be 2 multiplied by the 1.02, saved in your memory, multiplied by S. In other words, all we need to do is 16 squared minus 4 squared divided by the 2 times 1.02, and that will give us S. If we work that out on a calculator, it comes out as 117.44, or there, sorry, 144. In other words, we can then say that S is 117 meters to 3 significant figures, which is correct.